a cloud-delivered network security solution, and we also have Investigate, which is a search engine tool that allows someone like a security analyst to look in and get really powerful insight that is computed from the data that we see from our like 70 billion daily queries on our DNS network. So for today, we're going to talk about who I am, the team I work on, and what our role is in OpenDNS. We'll go into the project that I've been working on, which is called the IntelliDB, and how that sits inside OpenDNS as a company and how it affects our product and both our research as well. Then how we use that and researchers are able to leverage that to make more powerful research, then how that ultimately affects the entire process of how research is being conducted at OpenDNS. So about me, I'm a software engineer at OpenDNS. I've been there for about a year and a half, and I'm on the research systems team, and our goal is to provide researchers with very powerful tools and then ultimately serve as the connecting point from getting data from research or third-party sources and into our production environment so that it's actually enforced. So I mentioned the IntelliDB. I'll talk about it a little bit more now. And so for the engineers here, it's ultimately a distributed graph database. We built this primarily with TitanDB, which is an abstraction layer that hooks into HBase. We use Elasticsearch to index it, and we use Kafka to do really fast loading. But this is a security conference, so we'll focus more on that and what it means from a research perspective. So ultimately, it's a big sandbox of a lot of data. So we can take in third-party feeds from source like Kaspersky's feed or Mute, VirusTotal. They all provide really powerful lists of domains that we want to block. But we also can compute tons of data internally. So these are taken from our DNS log data, and we can say, hey, these are the most popular domains based on percentage of people visiting compared with IP requests. We have all sorts of jobs like that. DGAs can compute into it, DNS records, research prototypes, who is data, and one I really like is support tickets. So maybe someone emails OpenDNS and says, hey, this looks like it should have been blocked, or it's blocked and it shouldn't be. We have humans actually touching that data, and so we can take that from Zendesk, put it into our graph database, and it actually becomes really powerful data points. And so the key takeaway here is we want to see the relationships between all the data. And so the database itself is it contains all these metadata, and then when we want to know what to do, we ask the graph, and it takes in all these data points, and it will make a decision. So the obvious question would be, should this be blocked or should this not be? But you can do all sorts of questions against it. And so when we built this, we really wanted to make it work at scale. And so just one quick observation, it's really easy to spin up a malware attack. It's really easy to spin up a lot of them. And so in order for us to work against that sort of environment, we wanted to make sure that we could work in bulk with it. And so that means a lot of things actually need to be automatic. And that goes back to the point I just said where instead of something being determined by a human, we have our graph make that decision for us. And that's ultimately done from like the decision engine that we have, which is taking in all of that metadata and making a decision on the fly. And we want this system, it takes a long time to build something like this, and we want it to last for a long time. And so in order for that to work, we want it to be extremely easy for new research, new models, new data sources to be able to integrate, play well with everything that's already in there, and ultimately provide better insights to what we're doing. So let's just take a quick look at what the schema looks like in a graph, and then we'll talk about how that means for internally in our product. So let's say I have an internal source, and that could be someone like me, or it could be a DGA, it could really be anything, and it adds this domain. So we make a node for that. There will be a node to the TLD for it. So you could look up .com, and it would be a huge mega node. But this internal source has already also categorized it as malware. And so that's cool. Let's also look at another third-party feed. And so that third-party feed added a URL. It's And so I'm not a researcher, so these are a little bit generalized questions, but it is hard being a researcher because ultimately you have a lot of clues of where to look, but sometimes it's more art than data-driven. And so saying, okay, what exactly should I research? What's going to be the most useful thing for our customers to start adding to our product? And so you also might say, hey, I have a data set, and I've written some stuff to detect what I think I'm looking for, but what else am I getting? And how problematic will that be when I push this out to production? Will my data set be very different from what is live? And I'm not really sure how this will actually perform in the wild. So with IntelliView, what we're pushing right now is making data lead the way. So just for one example, we have like something like that support ticket I was saying, and we can pair that up with DNS log data and our internal stats. So for this example, we might have a bunch of Zendesk type tickets indicating an anomaly with a type of botnet attack that we don't have good coverage of. And we could look at our DNS log data and say, hey, we actually have a handful of customers that are actually seeing this. So this is something that would be more urgent than something that none of our customers are actually visiting. And so that could drive the decision to spend some time there and develop a prototype to start to detect and enforce that. And so let's say you create a prototype and you have V1, or let's say 0.1, and you just want to test it out and see how it works. You can integrate it right away with IntelliDB, and it would safely test against the environment. So the data from your model would be going into our database but not affecting production. But at the same time, you get to compare how it would, you could see how it would perform and get that relationship between the other nodes that exist there. So that gives very clear visibility of what's happening, and it, like when we actually send stuff to production, we're using that same database. So it's very clear of what actually is going on. And so when you actually would push that out, you'd have a lot more confidence about what you actually are sending out to start enforcing. And so a couple things that you could look for would be like whitelist. Is this whitelisted or not? Is this something that something else in our security offering is already covering? Would I be blocking new stuff or stuff that would just add more mass? And also, like, how many of our customers are actually hitting what is trying to be detected or blocked? And so what we have is what I call like a report card. And so bear with me, it's kind of a big table right now. But the first two rows are just examples of something that would be in our database for a long time. And let's say the second two rows are new prototypes that were added. And it helps you just at a glance get an understanding of what it's doing compared to everything else that we have. And then we start to indicate some anomalies that we see. So this prototype number 1, I highlighted in orange, percentage with no traffic. That looks like a lot of hits that you're producing that no one is actually visiting right now. And it doesn't mean they won't. What we try to provide are breadcrumbs so that our researchers can say, hey, I think this is a pretty good start. What should I do next? Where should I look next? And how can I make this better? And so we try and give stats so that they can see an anomaly, and then they can focus their continuing time advancing their model in the right spot. And so now that we've talked about how researchers can leverage our IntelliDB to create more powerful security offerings, as well as how it connects with our enforcement system, it just seems natural that it should just flow with this research development pipeline, as I call it. So let's just work with this on a timeline. And so we took our existing data that's coming into our database and providing clues of what we should do. And ultimately, there's going to be a decision for one thing or another to say, hey, we should focus some effort on this. So a researcher will start building some sort of prototype that will detect this, and it can be anything. I'm deliberately leaving this abstract. And after some point of time, they'll be ready to plug it into the IntelliDB. they'll see exactly how it would do with the report card that they give. And with the anomalies that we help indicate, that will give them clues of to how can I refine what I've built so far, how can I make this better, and ultimately there's going to be a point in time where it says, yeah, that data looks really good and we're ready to put this into the wild. And what's really cool is this whole time it has not had any effect on what we actually enforce in our product, but all we have to do is flip a switch to make it do that. And so that handoff procedure is super, super easy for us to do. And we've tested this the whole time, and we see what's actually going to be happening. So it's a lot more confidence while we go through it. I like to think of it as a puppet no-op procedure, if anyone here is familiar with that. And so the advantage that that brings is confidence, as I said just now. What we push out and what a researcher pushes out, they have a lot better understanding of what they're actually doing. And because we provide these clues to help them produce better research, they're actually able to produce these models slightly faster. And so that increases their velocity. But because we also give them these breadcrumbs, they know where to look, and our offering is a lot more accurate. And so always be advancing is kind of a slogan that we use internally. But what's really cool is our research is being pushed into our product, but then all of the data from our product is going right back into how we do our research. And so it's a continuous cycle. But because we take all of the DNS logs that we see, which are enforced by the security that we provide, and we push those back into our graph. And so we see all of that as it happens relatively in real time. And so in a summary, I talked about what my team does at OpenDNS, and I gave a brief overview of how the IntelliDB works and the design decisions made within that, and then how it sits inside OpenDNS as a data resource in between research and enforcement, how we leverage that data that we store in that database to give researchers a better way to produce what they do, and finally, the workflow that creates and how it improves our security offering at the end. I just want to give a huge thanks to not only BSides for hosting me and having this be an awesome experience, but also to the team that helps build this product with me, because it's not just a one-person effort, and it's been about a year and a half in progress so far, and it will be kind of an ongoing project, continuing to add new data sets, refine things, and always making sure our researchers are working fast and effectively. So that's all. I'll be happy to answer any questions, or afterwards I'll be out in the hallway. So thank you very much. Go ahead.